Hello all, welcome to our project Air Quality Index Predictor. In this project, we'll build a machine learning app with complete end-to-end deployment whose main aim will be to predict the air quality index with the help of certain machine learning techniques and using auto machine learning techniques. Now, in this project, we will be deploying our model with the help of Flask API, and I'll be showing you how to use the Heroku platform to deploy our model globally. So now let's proceed. Now before we proceed, let us understand what is AQI. Now AQI stands for Air Quality Index. Air Quality Index is used by the government agencies to communicate to the public how polluted the air currently is and how polluted it is forecast to become. You often have heard in your or you have seen in your mobile phone, smartphones that it often shows you the air quality index. Now, what is this? This is the measure of how polluted your air is. If your air quality index is higher, then it means that your air is quite polluted. Which, for example, if the air quality index is below 100, it is generally considered to be satisfactory. If the air quality AQI values are above 100, air quality is considered to be unhealthy. And now, if the air quality is greater than 150, then the entire population is at greater risk of a health effect. Basically, it measures the different number of dust particles or harmful organisms present in air, which suggests us that okay, what is the air safe for us? And generally, our air quality below 100 is quite good. So now, what we will do in this project, we'll try to build a machine learning model which will help us predict the correct air quality index with the help of certain parameters. Now, in this project, we have a data set of Bangalore city which has the different air quality index information. That means it has the different parameters, then it has its air quality index from the year 2013 to 2018. Basically, this data is not available directly. This is basically a web scrape data from a website which I have provided the link below. That is the Qtempo. In this website, you will find all the weather forecasts and weather information, and this data has been taken from there only. It has data, air quality data, forecast data, weather data of all the cities from all over the country from each day to day. It is pretty amazing website. You should check it out. So now what we'll be doing, we'll be first using the machine learning models, which I'll be seeing you in the notebook, what all models we will use. Then we'll be using the TPOT library. Okay, TPOT library is an AutoML library. I'll discuss it about in the next slide. Then we will also deploy the model. Okay, how will our model work as an app, as a web app? So we'll be using Flask API for deployment. We'll learn all of these in our upcoming sections. First, let us have a brief introduction of what is auto machine learning is and what is our TPOT library which we will be using. The machine learning techniques you all are familiar. I'll be using the normal basic random forest and that linear regression techniques. Then the new thing is the auto machine learning. Now, automated machine learning, also referred to as automated ML, is the process of automating the time consuming iterative task of machine learning model development and deployment. So now when we'll proceed in a project, you will see how I'll be using the different libraries and hyper tuning it and deploying it. And then you'll see how TPOT will do that in with a single lines of code, and which is a pretty amazing thing. The TPOT is a Python automated machine learning library that optimizes machine learning pipelines and use genetic programming. Okay, genetic programming basically works in the same way like a human brain does, the same way in the neurons does. That way the genetic programming works. The TPOT is here. TPOT uses genetic programming. It is a pretty popular library. TPOT uses a tree-based structure to represent a model pipeline. We'll see what is the best pipeline. We'll see that in a notebook session, in a code session. How TPOT does the data preparation part and build model algorithms and hyperparameters. Okay, that was all about our process and what are the things we will use. Now this is about the Flask API and Heroku. Okay, Flask RESTful is an extension for Flask that adds support for quickly building REST APIs. I hope you are all familiar with the APIs. API builds us the connection. Okay, connection to the server so that we can deploy a model. We can present our model in a more understandable way rather than presenting it in a code form. I'll be showing you how to do that and what all are the things required. And then we'll be using the Heroku platform. It is a cloud platform as a service supporting several programming languages. It is one of the first cloud platforms. I'll be showing you how you can connect to Heroku and how you can deploy your model with the help of it. Now moving on, this will be the timeline of our project. That is, the first we'll be doing the data analysis, finding out different relations, understanding our data. Then we'll be doing the feature engineering part. We'll be pre-processing the data and that things. Then we'll be building our model using the machine learning techniques like the random forest, linear regression, XGBoost. Then we'll shift to our automated machine learning part. We'll be using TPOT library. Then after all of that comparing results, we'll select one best model and we'll use Flask API to deploy it. Okay, that will be the model deployment. So at the end of this project, we'll be able to do all of these things. Okay, it is a pretty exciting project. So let's begin. Hello all, welcome to our project Air Quality Index Predictor. So now let's start our implementation of the project. So these are all the basic requirements or basic live knowledge of our project, which is the aim that in this project we'll be building an air quality index predictor with the help of machine learning models and AutoML library. And this is the data information that in this we are having a Bangalore city data which have the AQI information for year 2013 to 2018. And this is the website from which I have taken the data. This is the website. Okay, this is a very good, you should visit there. And this is a web scrape data. Okay, so when you'll go to Asia, then if you'll select India, then let's just select Bangalore. Okay, so see, this is the forecast data. Okay, this is the forecast data. This is all the data. Now if you'll just go and select air quality, then this will tell you about the air quality and all the different things. They go and select India, then you can see select the cities like this. Okay, so this is a very good website. You can have a look and you can try different data from here. You can see how you can do the web scraping, then you can eventually collect the data. Okay, then the next is how what will be the timeline of our project. That will be the data analysis part, feature engineering part, model building using ML, model building using TPOT, that is AutoML. The first thing we have to do is to import our libraries. So we'll be importing pandas, SPD, NumPy, Seaborn, Matplotlib, these for visualization, these for our computing and data analysis part. So now in our Google Colab environment, we'll import our file. So to import the file in Google Colab environment, you just have to import your file first in your Google Drive, then you have to mount your drive. What you'll do, you'll write this command. You can get this command by just clicking this button here and it will give you this command. Execute it, then it will give you a link. You have to just give the permission for that account. Just select an account, then sign in your account. It will provide you a link. Okay, copy it, then just simply you have to paste it here. Okay, press enter. It will take a second, 2 or 3 seconds. As you can see, it is saying mounted at content drive. Now when I'll go here, as you can see, here is my drive. Okay, when I'll select here and my drive, now these are all the files which are present in my drive. What I have to do, I want my train data. Okay, I have saved it under AQI data and I have already installed it or accessed it in my Google Drive. So this is my data, this is my CSV file. I'll copy the path and I'll just simply paste the path here and read it using pandas. Okay, so now this is our data. Okay, this is our data. As you can see, this is our PM level, that is the AQI level. If the level is above 150, it is considered a bad air part, very bad air part. If it is below 100, then it is considered quite good. And these are all the levels. This is the data of the Bangalore city. Okay, and this is the various parameters which I have understand here. That is, the T is the average annual temperature, TM is annual average maximum temperature, T small m is average annual minimum temperature, SLP sea level pressure, H humidity, V is the annual average wind speed, VM is maximum wind speed. Okay, then PM, this is a dependent variable, that is the air quality index. So now this was a brief introduction of the data and how you can read your data from the Google Colab environment. In the next section we'll be doing the same data analysis part, then we'll be proceeding with feature engineering, model building using ML, TPOT, then finally deploying our model. Hello all, welcome back to our project Air Quality Index Predictor. So now moving on to our data analysis part, we'll be seeing how our data is distributed and what are the different variables and in our data. So now let's proceed. We have already understood how our data was. I have and made you understood what were the different variables and all other things, right? So now let's proceed. First thing we'll do is we'll check the null values. If a data set is having any null values, so as you can see there are no null values in it, but the air quality index has one null value. We can obviously drop it because it will not make much of a difference. You can either replace it with the mean of that or median of that, or you can simply drop it. So if this is a very small in number, that is only one null value, so you can drop it. It will create no problem in it. So now when we'll see it, so now our data is set is clean, it has no null values. Okay, so now let's see what are the unique values. This command none unique will show you that which variable have how many unique values. Okay, so now PM 2.5 has 555 unique values, VM has 27 different values, V has 94 different values, TF 243 different values, like this. Okay, so now we can see that what are the data types of these values. Okay, so all are float, as you can see all are float. And when we can also see the shape of data set. As you can see there are 1092 rows, okay, and 9 columns. The 8 are the parameters and ninth one is a AQI, that is a dependent variable. And as you can see there are 1092 rows and 92 rows of data. Okay, so now let us see what are the how a data. As you can see all of these variables are continuous, right? So we can describe them on the basis of their number, like what is basically the count, what is the standard deviation, what is the maximum value, what is the minimum value. As you can see this is telling me the all the counts and the mean and the standard deviation and all other things. Okay, the count is 1092. As you can see that is 1092, so obviously the 1092 rows, the mean is there, the standard deviation is there, the minimum is there, 25%, 50%, 75%, max value. It has 8 rows and 9 columns, so it is the 8 rows and 9 parameters it is showing. So now if I'll just remove this print, then it will show me. Okay, so now see, now it is showing me all the variables, right? I used the print, that's why it was not showing me all the variables. So now let's see, this is the count, mean and all other information of all the variables. Okay, temperature, wind speed, humidity and all other things. So now let us see how our PM air quality index is distributed in the form of a distribution plot. What I have done, I have simply used the SNS library, and then I have used a function sns.diskplot. I have given the data DFPM 2.5. I have given the color. I've known the bins is 100, and I set the alpha value to 0.4. Now as you can see, our majority of the values lies below 100. Okay, so below 100 or till 120. Okay, so till below 100 the air quality is considered good, and between 100 to 120 it is considered moderate. So and very few after some of the data, some more values are above 300, which is very hazardous. As you can see, an AQI value of 50 or below represents very good air quality, while AQI value above over 100 represents hazardous air quality. Okay, so this is our hazardous quality. This is very few. As you can see, obviously some days like if the pollution is more or something of that sort happened, then the AQI value goes up. Okay, but most of the time the AQI value remains in the safe region. We have taken the big city. Okay, if we would have taken the data of a very small city, you would have seen that there will be less pollution, then the AQI will be less. What you can do is you can compare this data of various cities. Okay, this you can do, you can explore this with that website. It is a pretty fun thing to do. This is how you can improve your skills. Okay, how you can improve your knowledge, how you can improve your knowledge on Python, data visualization, web scraping. You will gain new skills. Think of it as an assignment and do it. So now what I am doing, that I am collecting all my columns in a list. Okay, so now I'll see. So these are all my columns T, T, M, T small m, SLP. I have collected them in a list. Then I'll iterate it through. Then what I'll say, then as we know that all of these are continuous variables, right? So they will be also be distributed, and we can see them in a form of distribution plot, just like we see the AQI part. So what I am doing, I am running a loop. I am saying for I in column, this is the column, I will be the each iterator. For I in column, plot figure, I am defining a size, and I'm saying plot a distribution plot, okay, and I'm giving the data df of I. Then I'm using the same values. What I'll do, it will provide me all distribution plots. Okay, see how beautifully it has provided me these plots. The first is the temperature plot. As you can see, these are basically logarithmic, normally distributed. Some of them, some are basically skewed right, skewed or left skewed. This is double normal, two chin normally distributed. This is normally distributed. Okay, so if we'll be doing these standard scalar techniques, so they'll all come to a common value. But as you can see how this data is distributed, right? So this is a pretty good thing for visualization. You can see how your data is distributed and how will it perform in the model, and you can gain maximum information from that, right? If what is the basic, what is the majority of the temperature, or like what is the majority of the temperature, and what is the maximum airspeed, what is the humidity and pressure at all of the time. As you can see that in this graph, we can see that the humidity, the majority of the days humidity is between 40 to around 60 to 80. Then very few days it is less humid, and it is a very few days it is more than 80. So these are all the informations you can gain. So now as you can see, moving on, this is now we can also plot a pair plot. Pair plot is a part of SNS library, which basically comes under multivariate analysis. Okay, what this pair plot will do, it will basically plot numerous amounts of plots. Okay, very numerous amounts of plots, and giving relation between each and every variable, plotting different scatter plots, in which we will see how that data is related on the basis of another data. It will also plot some bar graphs, which you will see when it will get executed. It will take some time, take around 50 to 60 seconds, like a minute, because it will be computing all of the different parameters, right? All of the different parameters, as you can see. So now how beautifully it has given me the plot, and you can see how my data is distributed. If it is evenly distributed and it is scattered all over the place from variable to variable, how you can see if this is like, if the data is like this, you can say that okay, the data, both these data, the T and the same data which is here, is TM is correlated, because it is providing me a straight scatter points, and this is not correlated, very badly correlated. And these all the informations, or you can provide, right? You can provide this information in a chart. You can represent this information to our employer and to present it in a report. This is a very impressive way of determining the things. Okay, you should learn and visualize things in this manner. The next thing what we'll be doing, to see the correlation properly in a numeric manner, we'll be plotting a heat map. I'll be writing a command df.core, which will be providing me the all the correlation. Then I'll convert this into a heat map. What I'll do, I'll take all the index top correlated features, I'll index from this, then I'll plot a big figure, then I'll plot a heat map saying that okay, plot this index, plot these figures dot core pf dot correlation. Then anot true, anot will basically, what anot will do, anot will basically overwrite your data. Okay, if I'll do the anot command, false here. Now if I'll do the anot command, false. So now see what will happen. There is no text. Okay, the text is gone. So what anot commands do, it overrides it makes sure that the text what is present comes onto your heat map. So this was our, if I'll just see my the relation part, that the relation variable, this is my table representation. Okay, so what it has done is just represented this into a more visual manner, and how we can understand it better. So in the form of color and different schemes, you can change the color schemes, no problem. So this is how you can plot a heat map. Okay, you can provide different relation variations. Hello all, welcome to our next section of our video, the next section of our project. In this video, we'll be seeing how we can do the feature engineering part. We'll be seeing at how we can see how if our data is normally distributed or not. If we have to change it, we'll scale our data. We will make our data model ready. So now let's proceeding with what we'll do. We'll plot a QQ plot. Okay. So QQ plot basically helps us is seeing that if our data is normally distributed or not. For that, we'll import stats from the scipy.stats library. Then also we'll also import pylab. Then what we will do, what we'll plot a function. Okay, we'll define a function plot curve. In that we'll give the data as df and a feature. In that I'll say plot a big figure. Okay, in that plot a subplot. In that first plot a histogram. Okay, so it will tell me how my data is distributed. Then second plot a probability plot. This probability plot will define give me a basically a kind of scatter plot and a line which will tell me if my data is normally distributed or not. As you can see, the distribution is normal. Then I'll just say the title and I'll give plot show. Then if I have to drive, well, I have to apply this, right? So what I'll do, I'll give a for loop for I in column was my column names. Then I'll define, I run this function for every I, okay, every attribute. So what it will do, it will give me beautiful plots, the QQ plots. Okay, now let's see that this is our plots. The first one is for the T. This is my histogram. Then this is my plot. Okay, this is a basically a scatter type of plot. So this is my theoretical quantities. This is my observed values. This is a probability plot. Okay. So now if the data is falling on this line, okay, it is if it is nearby, that means my data is normally distributed and I'm good to go. Okay. If the data is very much scattered from this line, that means that if my data needs some pre-processing, right? My data needs some pre-processing. I'll be doing some logarithmic transformation. I'll be doing some reciprocal transformations to see, okay, if my data fits my line or not. Okay, these are some of the data, but we can ignore them a little bit. For the sake of simplicity, I'm doing nothing. I'm just using the same data. I will standardize the data afterwards. Then it will be the same, but most of the data is falling on a line. Okay, so we are good to go. Okay, so now what we'll do, we'll divide our data set into dependent and independent variables. So we'll just divide the data in x, that is our independent variables, all the features. Then y is my pm value, that is my dependent variable. If I see my x, this is my x and this is my y. Okay, now what we can do, we can see which feature is the most important. For that, we'll be using a library which is the extra tree regressor. It can be found from the ensemble, from SQL and ensemble model. We'll just fit our model and we'll see print model feature importance. Okay, feature importance. What it'll do, it'll give me the importance in numbers. Then we'll simply plot this in a graph for better visualization. Feature importance, I'll convert that into a series. Then I'll plot it in a bar graph. Okay, now as you can see this, I got an idea of okay how my data is, how which feature is the most important based on my output. So this is my the most important feature TM, then followed by SLP, TW. The least important feature is my VM, the maximum wind speed and the other times. Okay, so now let's standardize our data. So our models, basically machine learning models, are very much particular with the standardized data. You must standardize your scale your data. You can do it either using min-max scalar, standard scalar. See whether which is giving you the more accuracy. Here I have used standard scalar. What this will do, this will just scale my values to a common platform. I'll just define this scalar, then I'll just fit my x values. Okay, I don't need to fit my y values. I'll just fit all my x values. Now if I'll see, it will be converted into an array. If I see what is my x now, as you can see these all are converted into an array. Okay, so now this will be fitted into my model, feed it into my model, so that my model will be able to understand the data better and give me the best results. And now lastly, I'll split my data into train data and test data. I'll just use train test split. So now my data is splitted. Okay, if I want to see the shape, I can what is my shape of my data? X train dot shape. So this is my shape, and now if I want to see my y train shape, so this is my y train shape. Now if I want to see my test shape, okay, x test shape. Okay, so this is my test shape. Basically, this is divided into a 70% train data, 30% test data. Okay, so this was our feature engineering, or you can say that seeing our variables, okay, making our preparing our data for model building part. So in the next section, we'll start building our models and doing prediction using ML models. Hello all, welcome to our next section of the project, that is the model building part. So as you can see, you are first using the machine learning. We'll be using the following models. First is the linear regression, XGBoost regression, random forest regression, and we'll be doing the necessary hyper tuning for the above. So now, first using the linear regression model, I hope you're all familiar with the linear regression model. It is the most simplest model you can learn, which is comes in the form of y is equals to mx plus c, the basic equation we all know, the basic maths equation. It works on that. It is a linear regression, right? So what we have nothing to do, we'll just import a model from sklearn.linear model to import linear regression. I'll just define my model, fit it with my train data. Then what you have, what the simply we know that what how linear regression works. It works on an equation. So y is equals to mx plus c, right? So it will be providing me the coefficients and the intercept, which is the the intercept. The c is the intercept, m is, these are my different slopes, the coefficient part. Then I'll see that how my model is performing in different data. So what I'll see, I'll import a cross validation score. I'll validate my data with this xy with 5 folds. Okay, I've given 5 folds, so it will basically run it, and for the 5 times on my data, give me a mean score. Okay, so what is my mean score? Okay, see, this is my mean score 0.471. Then I'll just simply predict my data, x test data. This is my prediction. Now if I want to see my predictions, I can just simply type, okay, this is my prediction. Okay, so this is my prediction. This is my air quality index for my test data. Okay, from my X test data. I'll just simply check it from my Y test data. So now distribution plot. Now as you can see, this is a continuous variable. How you can check the accuracy, right? You can just simply use a logic, right? What I have done is I have taken the test values, that is the original values, and the same I am differentiate. I am taking the difference of it from the prediction values. Okay, so if my values are correctly predicted, it will be giving me a least distance. Okay, if my values correctly predicted, that the difference is 0. Okay, so that is that distribution I'll be taking. So as you can see, our model has not that much correctly predicted, because there is a huge difference in many of the parts. Like see, there is a minus 100 to 100 difference in most of the region, and though the zero value is more, but the very more distributed values are from 0 to minus 100 and 0 to 100. So I can also plot a scatter plot. So now as you can see, my graph is quite scattered. Okay, so which means that my data, my predicted data and my test data, both are very quite not similar. So what I can do, and I can see that in numbers. I can give my mean absolute score, then I can use my RMSE, that root mean squared error. These are the all my values. Then I can import my R square. As you can see, our model has not performed that well. Okay, it is performed only with a accuracy of 48.5%, which is not very good. So this was just a general introduction of how we can import a model. Now we'll be moving on to more models, more unique models. That is, we'll be using the ensemble model, that is the extreme gradient boosting model. Okay, this is an ensemble technique. This, I am sure that this will provide us with a good accuracy. What I'll do, I'll just import the XGBoost model from the, and I'll from that I'll import regressor model, because this is a regression problem. If it was a classification problem, I would have imported XGB classifier. So now I'll define my XGB regressor. Then what I'll do, I just use the randomized search CV. There are two types. Okay, first is the grid search CV, and the second is the randomized search CV. So the difference between that is the grid search CV uses a particular data, particular folds of data. But in randomized search CV, what it will do, it will iterate through your data, it will iterate your data randomly. Okay, it will pick data from anywhere. Then it will check, okay, how what all parameters are there. Okay, so if your data is not very large, you can simply use randomized search CV. So it will be iterating all through there, and it will be taking less time. Okay, so now first we'll be defining the parameters. What I've done, I just simply researched on that what are the different parameters for regression, what are the best parameters. I have just simply defined it. For number of estimators, I've taken, okay, start from 100, stop to 1200, take 12 iteration by the difference of 100. So the estimator will be 100, 200, 300 for like that. Okay, and then this will be the different learning rates, the max depth from 5 to 30, this with a distribution of 6, then the subsample space, then the mean child weight. I am just defining these parameters. Okay, I am printing these. And then I am just storing that in a dictionary called as para. You can just simply Google about an algorithm and see, okay, what are its different parameters and how what can I use it. Then I'm defining my random search model. Okay, it is using XGB random. I'm giving the estimator as XG, that is I have defined here the XG estimator regressor model. I'm okay. Give the parameters distribution is param. Okay, these are the all defined my parameters. And scoring, right? Scoring is in mean square error. Okay, if I can also use the R square error. Okay, if I want to use R square, I can just simply write. Okay, I'll take this and I'll just paste it here. It will provide me a better area, okay, better idea. Okay, because R square is very much familiar, so we'll use the R square scoring. Okay, then I'll okay see that, okay, number of iterations are 100 CV5. So if we'll take the number of iterations 100, so it will take a very huge amount of time. Okay, so let's just reduce our iterations to 20. Okay, let's just reduce our iterations to 20. Then my CV is 5, verbose, I'll just reduce it. Okay, 1. The number of jobs is 1. Random state is this. I am just defining my model. Okay, XG is not defined. Okay, I've not used it. I have not defined the XG parameter. Okay, I have not defined it. Okay, now what I'll do, I'll just fit it. Okay, this is my fitted model. So now what will happen? Okay, sorry, it is saying me R square is not a valid parameters. Okay, so what we'll do, we'll just use the negative mean squared error. Okay, it is not taking the R square error. I'll just use the negative mean square error method. It will search on the basis of that. So now, as you can see, this will search all the different parameters, and it will see, it will iterate through different parameters. It will take some time. Okay, it will approximately take you around 5 to 6 minutes. If I would have taken, okay, the number of iterators also set to 100, so it will take around 10 minutes to get fitted. Okay, so because it will be checking all the parameters. So and by the time it gets fitted, where it get defined, then we'll just see that, okay, what are all the best parameters, then we'll fit our data with that. So what I did is I've already fitted my data. Okay, I've already seen that, okay, what are the best parameters, and I got these best parameters. Okay, so what I'll be doing, I'll just simply estimating that you can continue it, you can make it run. I'll just simply pause it. Okay, I'll just interrupt it because I've already gotten my best parameters. Like these were the best parameters which I obtained. You can obtain it using this simple command. Okay, you can run that. It will take around 9 to 10 minutes to get fitted. Okay, now I'll just simply fit my model with this. I'll fit my train data. Then I'll just see, okay, what is my predictions and what are my accuracy. I'll just predict my data. Then I'll just simply use the same distribution plot. Okay, now you can see that how beautifully it is predicted. Okay, the maximum density 70% of the data is in the zero part. Okay, which means that we have a very good accuracy. Same goes for scatter, it is in a single line. Okay, which means that, okay, it is correctly predicted many of the things. This is my MAE, mean square error, RMSC, and this is my score. As you can see, it is okay. I can just multiply it with 100 so that it will provide me the data. I provide me in percentage form. 81. Okay, 81% is my R square, which is a quite good square comparing to the linear regression. Now in the next section, we'll be using the random forest model. We'll be seeing that how a random forest regression model performs in a Hello all, welcome to our next section of the model building in our project. In this section, we'll be using the random forest regression model. In the previous model building sections, we have used the XGBoost model and the linear regression model. With the XGBoost model, we obtained a very good accuracy of around 81.7%. Now we'll see that how a for random forest regression model perform. So firstly, I'll import the random forest regressor and define it. Then I'll similarly like from the previous XGBoost model, I'll use the same random search CV parameter. I can also use grid search CV, but if a data is small and we want a good accuracy, we can use the random search CV instead of that. So now I'm just defining my parameters like the iterators. I've taken from 100 to 1200 with a gap of 112 parameters, maximum features, auto, square root, maximum depth, maximum sample spread, maximum sample leaf. These are the normal parameters which you can take via the documentation of the random forest regression. Now I have stored them in a dictionary. Then similarly I am just defining my model. I have defined my model with my RF estimator. The parameter distribution is param, obviously. Scoring, I have given neg mean square method, that is it will score on the basis of this parameter. Okay, iterations I have done 100, cross validations is fold is 5, then all the other parameters. Okay, so I'll not fit this model because it will approximately take you about 10 minutes to get fitted all over the model. So I'm just leaving it to you. I've already done it and it gave me these the parameters. It gave me the best parameters is n estimator is 500, minimum sample split 2, minimum sample leaf 1, maximum feature square root, and maximum depth 15. You can try it, you can fit it, and you can see that what are the parameters which you are getting. Then you just have to simply write rf random dot best parameter. It will take around 10 minutes to get fitted because it will iterate through all the iterators and the different jobs will be taken, so it will take some time obviously. So I'll just fit my model with my best parameters which I obtained, and I'll just fit my model with the trained data. Then I'll predict. As you can see, it got fitted with the same data. Then I'll just predict it and I'll find out the different distribution and scatter plot which we obtained from the previous sections. Okay, so now as you can see, this graph is also this graph also has a little bit of values greater than and less than 0, which means that this will be having a less accuracy than our XGBoost model. Let's see our scatter plot. Okay, as you can see, some of the points are scattered over here. Okay, so now when we'll see a mean and when see an accuracy score, as you can see, we are getting an accuracy score of 75.9 or approximately 76%. Okay, so our best performing model from all of these is our random XGBoost model. Okay, then the random forest followed by our regression model, which performed pretty badly. So after all the hyperparameter tuning, we found out that this our XGBoost model was the best, and then we'll use the same model only to pickle our file. Okay, so now importing pickle for development. Pickle basically helps us in deployment. Okay, if you want to deploy your model, you want to run it in Flask API, you have to convert your file into a pickle file. What I'll do, I'll just import pickle. First you have to you might have to install pickle if it is not present in your machine, but usually it is there. So if it gives an error, just install it and see the documentation of pickle, install it. Then I'll just say that file that open. I'll give a name AQI XGB rig model. I've given this nil.pkl. I've written write base. Okay, so what it will do, it will open a file and it will say that it is write, which means that a data will be written it, and then I'll say pickle.dump, and I'll saying that XGR is the model which I defined my the XGBoost regression model, and then I'll say that dump this model into this file. Okay, so it will just basically dump this model and into this file. Okay, sorry, I've not defined it because I started my kernel over, so I'll just define my model, the XGBoost model. Okay, now what I'll do, I'll just use these parameters. Then we'll just fit our model with the same parameters. Okay, so now my model is fitted. I'll just simply use that model in my pickle file. I'll just use it again. So now my model is picked. If I want to see which model I have given, I can write XGR. As you can see, this is the model which I have pickled, which means that this model is stored in a pickle file. Okay, so now this model is stored, so this model will be stored in your Google Drive. Okay, it must be somewhere here. Okay, Okay, as you can see, this is my AQI XGBoost regression model. This is my pickle file. This has been stored in your Google Drive. You can download this file, and then I'll show you how we can deploy this. But after, in the next section, first we'll see that how we can use this, all of the auto machine learning part, to do all of these things to the till the model deployment and the model building part. Okay, so we'll be using the TPOT auto ML. I'll be telling you what auto ML is and how we can automate all of this process using this library in the next section. So hello all, welcome to our next section of this project, that is the automated machine learning part. So previously in our videos we have seen that how we can build a model, and we have built a model which is predicting our air quality index. Now we will see how we can build the model using the auto machine learning part and see how our model performs. So as I've told you in the introduction part, automated machine learning, or also referred to as auto ML, is the process of automating the time consuming iterative task of machine learning model development. The same thing which you did above using the linear regression, random forest and XGBoost model, they will be using the TPOT auto ML to remove all that hassle and do the same thing in some single lines of code. So a brief introduction about TPOT auto ML. So TPOT is a Python automated machine learning tool that optimizes machine learning pipelines using genetic programming. Okay, so genetic programming basically works the same like a human brain does. Okay, it works on the basis of that. So the TPOT uses the genetic programming concept. So the first thing we have to do, we have to install TPOT. Okay, you can simply install TPOT by writing pip install TPOT. It will install all the necessary libraries and all the different functions. Like first it have installed the TPOT, then it's, as you can see, it's installing the XGBoost model and all the XGBoost related model, then all the different models. Okay, so as you can see, my teapot is being installed. If you want to install it directly in your command prompt, you can install it there also. But if you want to install, if you want to see the installation in your Google Colab environment or your local Jupyter environment, you just simply write the command pip install teapot. Okay. So now, as I have already finished my runtime, so now what I have to do, I have to restart my runtime, right? I have to restart my runtime because what happens is when you install a library, the Google Colab will not read it unless and until you restart it. So you just have to restart your runtime. Now I've already installed it, so I don't have to do that again and again. But if you are installing it for the first time, you must restart your runtime. So this, I simply imported my teapot and I printed my teapot version. Okay, then I'll just import from teapot, teapot regressor, because this is a regression problem. I'm using the regressor, so it will import all the regression libraries present. Then I just use the data present above in my column, which is the data which I use for my machine learning models, the X and Y. I'll simply put it into X train, Y train, and I'll just see the shape of my data, what are the different data shapes. Then what we'll do, then what we will do, we can define the model for evaluate. Okay, what we can do, we can use the teapot library in folds. Okay, we can use the cross validation so that it will check the data, check our model on the basis of different folds. Okay, I'm taking repeated k fold, I'm taking the number of splits is equals to 10. So then when I'll fit my model, I'll define my model, I'll just use teapot regressor. Okay, CV is not defined. Okay, I did not define it, sorry. Okay, now I'll just fit my regressor with the generation is equals to 5. I gave my population size is 50. In their scoring, I use the negative mean square absolute error the same, and then I'll just use the following things, and I'll just fit my model. Okay, now when I'll fit my model, it will take some time. Okay, it will take around 5 to 10 minutes again to get fitted, because of the fact that it will iterate many different times. I provided the CV is equals to 5 and all of the other things, so it will take some time to get fitted. So what you can do, what you can do, you can wait for some time around 5 to 10 minutes to, so that the model will get fitted. Also the thing is you can also set the minimum number of times. Okay, you can select the maximum number of time. Let's say that, okay, submit use this much of amount of time. Let's say select 10 minutes, and then you can say to the model, okay, use 10 minutes and give the amount of model which give the result which you have got. Okay, don't go any further. You can also do that. I have just shown you how to use the TPOT and how to define the model. Then you have to do the same things, right? You will just fit your model with the train data. You'll print the score of the, you'll print your model score, that how your model is performed. Then you can also, you can see which is the best fitted pipeline. Okay, what it will do, it will give you the pipeline which the model is selected, and it will be it will be all the information, like the all the how, what where the model is selected and what are the hyper parameters which are selected. Then just you can simply predict and check the accuracy like the previous one which we did. Okay, so now this was a brief introduction. This is similar, as you can see, what we did previously using the linear regression model, using the using the XGBoost model, using the random forest model. We wrote so many lines of code. Okay, we wrote so many lines of code. We defined different number of parameters, and even though we missed some of the parameters, I am sure of that, we might have missed some of the parameters, but by using the TPOT library, TPOT regressor library, what it is doing, that it is doing that thing all of by itself. Okay, it is taking the model, it is taking the hyperparameters, it is seeing okay which models performs the best, and it is giving me the best model. Okay, so I've this might take some time. It will take you around 5 to 6 minutes to get fitted. Okay, so I'm not just making it complete. You can see for yourself that how your model is getting fitted and what is your best pipeline. You can just simply see the accuracy and compare it between your ML and different ML and auto ML. So now this was all about your project and how you can build your project using the TPOT library and the machine learning libraries. In the next section, we have to deploy our project. Okay, so we'll learn how we can deploy our project to the outer world, and to deploy our project using the API. We'll be using the Flask API to deploy our project, and I'll be telling you how to do that in the next section. Hello all, welcome to our deployment section of our project. So in this section, I'll be telling you how you can deploy your model with the help of Flask API. So first of all, what you have to do, you have to use a IDE interface. I am using PyCharm for this. You can use any of the, you can use Spider, or you can use Atom, or any of that sort you want. So what you have to do, first you have to create a folder. Okay, first you have to create an empty folder. Then you will be requiring the following files. First you have to create a Python file. This is the app.py file. This is the main file which is required. So now what we'll do, we'll first import the libraries. Okay, we'll import Flask. From Flask, import Flask render template URL for and request. These two are not required for the time being. So for the main library is our Flask and render template. Flask is our Flask API, and render template is the command. Okay, is the command which will through which our model, through which our web application will read the templates. Okay, so what we will do, we'll import pandas, we'll import pickle. Then what I'll say, I'll load my model from the disk. Okay, so what you have to do, the folder from where you are, the folder where you have stored the api.app.py file, you have to store your model.pickle file. Okay, so this is the folder I created, in which, as you can see, this is my app.py file, and this is my templates folder, the different template folders. What you can do, that first you will load the file, you will just say load model pickle.load. I'll say open the model which we have stored. Okay, the pickle file which we have stored, it will just open. Then I'll say okay, Flask. It will tell the template folder is my template. Okay, I'm just defining my Flask here. I'm defining my Flask API. App is equals to Flask name. I'm giving template folder is equals to template, because I've stored my template in a folder called as folder known as template. Okay, as you can see here. Okay, so now what it will do, I'll just say then, okay, app.root, this is the command which you have to write, and you can say I'll define a function from home. In this, what it will do, it will render, it will take my template of the home command. Okay, I've simply made a simple HTML file in the templates. As you can see, I've simply made, this is my home file. Okay, this is the template which I have made. If you want to see the source of it, this is my HTML code which was required to write. This is a very simple HTML page. You can also use the various visualization methods to make it a lot more better. This is a simple HTML page where I've written machine learning app with Flask, air quality index prediction. Click the predict button, it will just simply predict the results. I've written this is a sample project in which I have taken data directly to show how the Flask API is used. Okay, in this app, I am not taking any data from the user. What I am doing, I am just simply giving my data from the app.py file itself. How? Let's see that. I'm then the second command is app.do predict. So what predict? Now what will happen when I'll click this predict button? Okay, when I click this predict button, so okay, sorry. When I'll click this predict button, it will run this command. Okay, it will run this command, and what it says that df is equals to pd.read csv. The real 2018, this is a test data which also I have which also a web scrape data of the website. This is a particular data of the 2018 year of a particular city. Okay, in this no AQI index is present, only the parameters are present. If I have provided you the data also, you can also have a look at it. I'll just use loaded model, the model which you have loaded dot predict the all the results. Okay, it will just predict all the results, and I am selecting only the files which are independent files. Okay, I am just selecting the independent files. I am not selecting the AQI file, AQI index. Okay, now I'll just store my predictions in a list. Then I'll say okay, render template. What render template will do? It will just fetch another template which is the result template. Okay, the result template is this. Okay, this is also I have made it. Now this is if you want to see this page source, this is the HTML command which is used to make this. This is a simple result template. It will display this. It will display the results here. Okay. So now what I'll do, I'll just this okay, it is done. Then I have just displayed my results. Then I'll say okay, if name is equals to main. This is basically a basically a basic Python command to run the part to run the code. I'll say app.run debug is equals to true. I'm getting debug is equals to true. So what will happen? There is some error. It will show me. I'll just simply run the file. I'll just run the file. It is, as you can see, it is getting executed. Okay, now it has given me a link. Okay, it has given me a link. It is saying that okay, running on this server. Now in this thing, what it is going that this web app is running on my local environment. No one can access it. I can access it only via this link. If I'll click here, as you can see, okay, sorry, there is some, it's saying template not found. Okay, okay, I have defined my folder as templates, not template. What you have to do, you have to write, take care of the name. Okay, beware of the names what you are writing. Then I'll just I'll just run it again. Now it should work because I have given the template folder is equals to template. If I would have said you that okay, template folder is equals to templates, then it would have run more, in a more proper way. So now let's see how it will run. These are very few single simple amounts of codes. Okay, as you can see now my app is running. When I'll click the predict button. Okay, as you can see my air quality index is predicted. What it did, it basically read that data, read that test data which I have given the real 2018, and it predicted the data with my model. Okay, so this was a brief demonstration of how you can predict the data and how you can make your own web application. Okay, this was a very basic command, very basic thing. What you have to do, you just have to create a folder, create an app file like this, and now create all the template folders, and the static folder is also the in the test used in the template folder. This basic requirements of an HTML page. So now what I'll show you that now this what happens is this is running in our local environment, right? This is running in our local environment. So now what we can do, if I want to deploy this model into a more into a proper environment, so that with a URL, so that people can use it, what I'll do, I'll use the platform called Heroku. Okay, I'll use the platform called Heroku. I'll just go here. What you have to do, you have to sign in here, make an account. It is free of cost. You just sign up here, make an account, and okay, this is my rating. It is getting okay. I'll just log in here. Okay, this is my Heroku dashboard. Okay, this is my Heroku dashboard. You just have to log in here. As you can see, I've now if you want to create a project, what you have to do, you have to create a GitHub account, GitHub repository. Okay, in order to read the in order so that the Heroku can read your files, you have to create a GitHub file. What I have done, and these are the basic requirements you need. Okay, first is the license file. I provided you all the file which you have. You have to provide this license file. You don't have to do anything. You just have to insert these files into your GitHub folder. Second is the profile file. This is the profile file. You just have to insert these files in a GitHub folder. Then this is the this is the data. This is the app.py file which I have created. This is my pkl file. This is my test data, and this is my requirements.txt. This is basically the requirements of the libraries which my Heroku will be installing. It will be reading from here. It will installing all the libraries. Now what I have done, I've imported all my files in my GitHub folder. So now I'll just simply I'll just simply go to my Heroku platform. I'll just simply just log in here, and I'll click on new. I'll say create a new app. I'll say create a new app. Okay, it is not running. Okay, now I'll just create a new app. I'll just go to Heroku. I'll say create a new app. Then I can just write an app name. I'll just say write name demonstration or AQI. Okay, this in demonstration AQI is available. Choose the region to United States only. Then I'll create an app. Now what you have to do, you have to make a Heroku read your data. There are two ways to do. First, you can use the Heroku git command, but that is a more complex command. You can just connect to GitHub. Okay, that's why I created a repository to GitHub. You can see, you can insert your GitHub repository. You can search your name. My repository name is AQI. I'll search it. Okay, this is my AQI. I'll just connect it. Okay, what it will do, it will take all my data. It will take all my data which is present in my repository. Then I'll just say deploy. There are two ways. First, you can use the automatic deploy, and the another one is you can deploy your deploy from your branch only. I'll click on deploy branch. Then what it do, it will deploy my model. Okay, it will deploy my model, and it will just take a few times to import. Okay, it will just take a few times, a few minutes to get imported and build your model. At the end, what it will do, it will give you a URL. Okay, it will give you a URL, and the same app will run in the local, not in your local environment, but in your web app. Okay, it will work as a web app. It will take some time. As you can see, it is installing all the libraries. It is installing all the libraries, and after that it will give you an URL which will be saying that okay, deploy to Heroku. Then your model will be deployed. When you'll click on that URL, you'll just simply go to this model. Okay, you'll just this page will open. Okay, so this was a brief introduction of a very brief introduction of how you can deploy your model and how you can use Flask API. For that, I have attached all the files, all the different files in it. Okay, all the different files in it which are required for your execution of your and deployment of your file. You can have a look, you can see it, and you can see this video and deploy your file with this project or any other project. Thank you.